Hi, this is example number 2 of section 15.4. We are talking about collision in particles. So we have one ball that is traveling 20 meters per second towards a wall. So it hits the wall and they gave us the direction 30 degrees under, and it collides right here and it goes to the other direction. So we are asked to find this velocity, which we can call velocity of bulb 2. And when they ask us to find the velocity of bulb, it's not only the magnitude but also that angle. So we actually have two unknowns because we have the magnitude and the direction. See, any vector has two unknowns. So we need two equations, right? What are we using? So the solution. We can draw our impact diagram of our ball during that collision, right? And if we draw our impact diagram, we have our ball and we have this impact, which is, remember that it's not a force, it's an impact. So since the impact has a very high magnitude, I will not draw the other forces. The other forces would be, for example, the weight. So the weight in the impact diagrams is neglected because the impact is so much bigger. So which equations are we using? As you see here, we have to have our, I'm going to draw my coordinate system. This is a very first step. And what do we notice here? That this impact is only in the x direction. So in the y direction, we don't have any impact. So if we use our impact equation, so additions of all impacts in the y direction will be equals to the linear momentum in the y direction for final position minus linear momentum of the y directions in the initial position. And we notice here that we do not have any impacts in the y direction, right? So this is 0. So we can say that there is conservation of linear momentum in y direction. We cannot say that the whole system has a linear momentum conservation only in the y direction. So we can write that the mass B times the velocity in y direction in the initial position, and since I have only one ball, it will be equals to mass B in the times the velocity of the ball in the second position in the y direction. So this is mass goes with mass, and then we just say that the velocity are equal before and after the collision in the y direction. So to get the y direction, we will have the velocity of one is given, so that will be 20. In y direction, we have to convert that we project that, and this will be 20 meters per second sine of 30 degrees, and that will be the position, the velocity, which is not known, be in the final direction times sine of theta, which is unknown. And this represents our first equation. So we have one first equation with two unknowns. So we have unknowns, velocity of B, and direction. Okay, what would be my second equation? So this is my first equation. My second equation, I will use the coefficient of restitution. And very important that we use our coefficient of restitution along the impact line. So that's very important because you have to also decompose the velocity. So what is the impact line? The impact line is in x direction. So this is the impact line. So, what is the definition of the coefficient of restitution? The relative velocity of separation divided by the relative velocity of approach. Of course, in this case, the wall is not moving. So let me write the whole equation. That's the wall in x minus the ball in x over the ball y in x minus the velocity of the wall 1 in x. Obviously, the velocity of the wall is 0 and the velocity of the wall is 0. So we can get here that this is negative velocity of v2x over velocity v1x. So that means that the coefficient of restitution, which is given, this is 0.75. So what do we have? We have that the velocity 2, if you look at my diagram, the velocity in 2 is going towards the negative direction of x. So I have to write, so be careful with the sign, is what I'm trying to tell you, is that this is a negative, but inside my magnitude is also negative because it's going in the opposite direction of x. So it's negative velocity of v 2x, which is what I'm trying to find, right? And then here I have the velocity in x, which is positive, which will be 20 times cosine of 30. And this is equals to 75. So this is our second equation. We can write our second equation will be then velocity of v2x, and velocity v2x is v2 cosine of theta is equals to 0.75 times 20 cosine of 30. Well, I could actually substitute cosine of 30 by square root of 3 over 2, but we can also, well, since I already wrote here sine of 30, I'm going to leave it as cosine of 30. But what I meant is that's known. So, and that represents my second equation. So as you see, I have two equations. This is 2. And from here, we can solve them very easily. Solving 1 and 2, we can see that if we divide them, we can have the tangent and the velocity of v cancels out.
With the inverse tangent, I find theta.
Theta is equals to 37.6 degrees, and we can solve for velocity of v once that we already have that angle, and the velocity of v is equals to 16.4 meters. Let me write you, so for you to solve, the partial results that I got is that velocity of v in x is equals to 12.99 meters per second. Velocity of v in y is equals to 10 meters per second. Okay, so those are the results. The final results that we were looking for are those two. Remember, you can relate those two also by taking the square root of the first to the square plus the second to the square. So that's the definition of magnitude.